So as we were covering here in the last session, or last recording anyway, zero force members are found by looking at a joint and drawing up a free body diagram, I guess you'd say, and then summing forces in a particular direction. And when you do that, you should have only the member acting in a given direction. No other members, no other applied forces. And then you can prove it's zero. So we looked here, we looked at the sum of fx at joint A, and the only thing acting at joint A in the x direction is AC. So that means that FAC is a zero force member. We did the same thing at joint D in the y direction. Sum of Fy is 0 for joint D, and from that we can conclude that FCD is 0. It's the only thing acting in the y direction on joint D. Now, when you find these zero force members, you typically just want to focus on one joint or the other. Notice that both AC and CD go into joint C, and you really couldn't conclude much about them by looking at joint C, because there's 1, 2, 3, 4, 5 members coming into joint C plus that load. So there really isn't much you could conclude about them looking at joint C, but you can conclude a lot about them by looking at either joint A for AC and D for CD. Now there is one other zero force here, and the way to find it is to look at joint A, and when you go sum of Fy, you can set that equal to 0, and that will just be FAB. So what we have here then are 3 zero force members in this truss. And to find them, again, we're just writing equilibrium equations for the different joints. And we're looking for a joint in which there is a member acting in a particular direction, only one member, and no applied forces. So based on your sum of F equals 0 equation, you can then prove that that member is 0. Now, this truss shows some of the typical locations where you see zero force members. One is an unloaded corner with no applied forces, and only 2 members coming into it. So notice that joint A is an unloaded corner with no forces applied with 2 members. So from that we can find that AB and AC are 0. Now notice joint F is an unloaded corner, but it has 3 members coming into it. You can't really conclude anything from that, because you can't really write up an equation that will only have one member equaling 0 for that joint. With the 3 members coming into joint F, there's just too many members coming in there to make any zero force conclusions. Okay, the other common place where you can find zero force members is an unloaded T joint, such as you see at point D. So what you have there is DB, DF, but then you have a third member, CD. Now DB and DF make a straight line, so they're probably going to be equal and opposite in force. So I couldn't conclude too much about them. But CD, the off member, the member that is not in the straight line of the T, that is 0 if it's an unloaded T. Okay. So let's have a look at some others. Let's look at the next one here. Right there. So let's look for zeros. All right. If you want to pause, you can have a look and think it through a little bit. I'll just probably just go right ahead and work on this though. Okay, what's going on this one is, we've talked about standard XY axes, but you could also have axes that are at angles. So you could have this. Okay, and if you look at joint B, what you have there is there's some angle here, and we can call it whatever we want, call it theta, between BC and ABD. Notice that ABD are in a straight line. BC makes that into an unloaded T intersection at B. So if I go sum of Fy prime equals 0, which I can do, what I'll have there will be the sine of theta times whatever FBC is. Well, it doesn't really matter what theta is. All that will do will be to add a coefficient to our equation there. So regardless of that angle, FBC will be 0 because it's the only thing acting in the y prime direction. There's no other force or member in that direction. So if that joint B is in equilibrium, BC is 0. Okay, so that's one of them. Now the other one is a little bit odd. It's over here at joint E. And what I could do, I could go sum of fx and set that equal to 0. And I could call that angle phi, let's say. And what that would be, being as I'm on the opposite side now, if I use a right triangle using that as my hypotenuse, I'm at the opposite side, so that would be sine phi of FDE. Okay, and I would probably just move that over here. That would be the sine of FDE. Okay, and so that would be 0. So what I can conclude then is that FDE is 0. Now this is kind of an odd one because I've got the force up here that's pushing. The assumption is that force is directly in line with EF, and that only EF is required to support it, which again depends on those things making a perfectly straight line. If that's the case, then FDE is 0. So this is one where, we look at the geometry and we go with that the load P is right in line with EF. Essentially what that makes then is a T intersection at E with an angled member. And so sine of phi then times FDE is 0, so FDE equals 0. All right. So in this stress, we're seeing that these angles don't matter so much. They just add a coefficient to the equation, which doesn't change the fact that those members BC and DE are 0. We're also seeing that we can use inclined axes to analyze joints, as we can, we could use inclined axes whenever we want in statics. It's a good trick to know about when you're analyzing things. Okay. All right, now the last one is right here, so have a look and see if you can find the 0 forces on this one. Okay, so you could pause and have a look and then start up when you're ready. All right, so I think we could see this one pretty readily. If I go sum of Fy here and set that equal to 0, what I've got is FBD is 0. So that's a 0 force. Now, once you find that BD is 0, you can take it out of the truss, is what you can do. It's like it's not there anymore because it's 0. It has no function. It has no force in it. What you can do then is come up here to joint D and go sum of Fy prime and set that equal to 0. And whatever this angle is in here, again, it doesn't matter what it is. That would be sine theta times FCD. So we can conclude from that FCD is 0. Okay. So once the point here is once BD is identified as being 0, it's as though it's not there. I can then go up to joint D and analyze it. All right, now there could be one other here. This one's a little bit more involved in the analysis. I could assume that the reactions would be up here. I think that's a reasonable assumption. Now the big assumption here would be that RGX is 0. If that is 0, which I would assume it is because the only load I have is vertical, what I could then do then is just go sum of Fx for joint G, and I can come up with that FCG is 0. Okay, and so I have to do a little bit of analysis to conclude that, so it's not quite so easily seen, but I think you could assume that the reaction at G is only in the y direction, okay, that RGX is 0. And if you conclude that, you can get that CG is 0. Okay. So when we look at joint B, we get that BD is 0. Once it's 0, it's gone. We can go up there to joint D and do sum of Fy prime, and that'll be FDC. I guess I have that perpendicular here, and I did add a sine theta to it, just using this as the angle theta. Hard to tell if that's a right angle or not. I have no dimensions on there, so either way, it doesn't really matter. Okay, so FDC comes out to be 0. And then also I have that little bit more involved one there at joint G. So sum of Fx is 0, so that would be FCG. Okay, so that's just a run through on finding 0 force members. I have assigned some problems here, 301 through 305. And that's right on a page of the packet. So all I really need you to do is to pull this page out and just mark the zero force members with a 0 is all I need you to do. So I don't need any write-up on this. I really don't even need any great amount of analysis on it. You can just mark the zero force members with a 0, and that's really all you need to do. And I'm flipping through my book. I'm pretty sure that's page 18. Let's just make sure. Yeah, it is. So page 18. So all I want you to do on this is mark the zero force members in the 5 trusses with a 0. Okay, that's all you got to do. So there you go. So that's just a bit on zero force members.